Today I am going to talk about the use and misuse of statistics in life sciences and healthcare. So before talking about the use and misuse, see what is statistics? Statistics is a science concerned with uncertainty in real life. It plays a vital role in scientific research. Irrespective of the field of study, statistics is involved from the beginning to the end of any research. Scientific research is based on mathematical modeling. Statistics is mathematics of uncertainty. And the real world is full of uncertainty. Therefore, the role of statistics in scientific research is invaluable. In statistics, what we do is we use statistical techniques for data collection, analysis, evaluation and interpretation. Then we present the information to solve the real world problem. So what are life sciences? Life sciences are concerned with the study of living organisms. So life sciences include biology, botany, zoology, microbiology and many other related areas. Healthcare. Healthcare is the maintenance or improvement of health, where the prevention, diagnosis, treatment, recovery or cure of diseases, illnesses and other physical and mental impairments in people. So you all are either from biological sciences or healthcare. So the role of statistics in life sciences and healthcare, you all are aware of that. As I said earlier, in every research you conduct, you use statistical techniques. In biological sciences, medicine, pharmaceutical and healthcare, etc. So from the research design to the final presentation, statistics is very useful. However, most of the studies are not really benefited from statistics due to misuse of it. What is this misuse of statistics? Misuse of statistics is a pattern of unsound statistical analysis. It can be a result of mistakes or negligence, lack of statistics knowledge or purposive. That means like when we enter the data, in the place of 10, we might put 100. It is a mistake. Or you don't know the statistical basic concept properly. Therefore, you make mistakes. And purposely, you know what you are really doing. But to get a certain result you want, you misuse statistics purposely. So these are the three ways where misuse can occur in statistics. A statistician across the world suggests that at least half the papers published contain serious statistical mistakes. I am a member of American Statistical Association, Statistical Society of Australia and Statistical Society of Sri Lanka. So everywhere in the world, the statisticians are trying to overcome this misuse of statistics. So we all have forum discussions and the ways of doing it. So these some of the ideas given by the world statistician. Professor Andrew, a biostatistician, he says, misuse is not a rare occurrence. It is very difficult to correct it because the researchers say that is what all the journals are used to do. That's how everyone is doing in my field. So, like when I say, when we talk about the misuse, this is the main problem. Because if you take some peer-reviewed journals even, or the documents published by world high-ranking universities contain serious statistical mistakes. So then, those who are following them also naturally follow these wrong methods. So that's what the Professor Andrew says. It is so difficult to push it back, but somehow or the other we have to do it. Because no point of doing a wrong research. It is better not to do it. Why am I saying so? Imagine if you conduct a research, especially in biological and healthcare, you are playing with the life. So, if you outcome with a wrong finding, you can kill thousands of people, or you can make long-lasting problems to the society. So then the misusing of statistics is not a simple thing. So for example, by using wrong statistical techniques, you might conclude that a certain medicine is good for human, but actually when it is not. So what are the outcomes? Another statistician say the problem of poor statistical reporting is long-lasting, widespread, potentially serious. However, the good thing is it can be corrected easily by avoiding basic statistical techniques mistakes. That's a good thing. Following few guidelines, you can correct your things. And another professor says, biologist. He's a biologist, that's why he says. Biologists all too often act as if mathematical techniques possesses magical powers. That means most of the researchers think, okay, I'm doing a good software, so I will get good results. They assume that the software can make a miracle. Whatever the software you use, your outcome depends on your input. If you put garbage in, you will get garbage out. So if your research design is poor, if your data collection methods are wrong, then whatever the software you use, its outcome is useless. And another researcher say, medical researchers, he's a medical researcher, that's why he says about his field. Medical researchers to be ignorant in statistics. They are not ashamed, or some are proud to say that they don't know anything about statistics. Professor Douglas says so. So what are the common misuses of statistics in scientific research? According to the statisticians across the world, these are the common mistakes. Using non-random sampling techniques, especially this convenience sampling in research, that is the biggest problem. Secondly, misinterpreting the measurement scales. You know, there are 4 measurement scales: nominal, ordinal, interval and ratio. And many research, especially in psychology and the sociology, psychology and many other research, we use Likert 5 scale. It is an ordinal scale, but misinterpret it as an interval scale. So this makes a serious problem in data analysis and interpretation. And when running regression, another problem. Like in simple regression or multiple regression, dependent variable has to be normally distributed. It has to be numerical. But for categorical data also, the people use this. And including non-significant variables in models. Not validating and verifying models. In regression or time series or whatever the area, researchers pay least attention on validation and verification. That means checking the model assumptions like ifs regression, checking the normality and independence of residuals, and calculating the measurement of errors. Then using 2/3 of the data for model validating and 1/3 for model verification. Those things are ignored, or they are not aware of those things. And another issue is using parametric test like Z-test, T-test, and ANOVA for hypothesis testing related to categorical variables. Categorical variable means if the variable is measured using nominal or ordinal scale, they are categorical data. Then the non-parametric test has to be used for them, but the researchers across the world use this parametric test. Misinterpretation of the data analysis of outputs. That is sometimes like due to lack of knowledge, most probably purposive. You interpret your data outcome as you really want. Another thing is p-value hacking, and it is called data thug also. P-value hacking and data thug. P-value hacking is like let's say for example, you are going to introduce a new medicine. So you want to show that it is significant. So when your result is not significant, say at 5% level, you change the data set. Or you put it to 10% significance level. So that kind of things, p-value hacking. And among all these things, one of the most crucial thing is not paying attention in designing research. Mostly researchers assume that they can do everything correctly at the data analysis step. So they don't pay attention on research design. That is the main problem. So you have to pay really a good attention and design the research properly. For that you need to have some good understanding about the overview of statistics. Statistics we mainly divide into two parts, descriptive and inferential. In descriptive statistics, we are describing the sample data through measures of location, that is mean, median, mode, proportions and all, and measures of dispersion like range, interquartile range, variance and standard deviation with them. So whatever you describe in descriptive statistics are valid only for the sample. You have no right to talk about the population with descriptive statistics unless you conduct the inferential statistics part, that is hypothesis testing and interval estimation. Interval estimation means obtaining confidence intervals. Hypothesis testing, conducting the appropriate hypothesis test. It can be Z-test or T-test or ANOVA, Wilcoxon rank test, whatever the corresponding or appropriate test. That is the overview of statistics. If you stop your study at descriptive level, you can report that, no harm, but you can't talk anything about the population until you prove it by the inferential statistical techniques. As I said earlier, most important part of a study is research design and data collection. If the data has not come from a random sample, then the descriptive statistics become bias estimates for population. Descriptive statistics you obtain from the sample data, and using them you conduct the hypothesis test. So for example, you calculate the sample mean as an estimate for the population mean. Then if your sample is not representative to the population, your sample mean is biased. It is a bias estimate for the population mean. So then all the other analysis and outcomes will be biased and mostly useless. So you have to pay a good attention in sampling. Sampling methods. We mainly divide into two parts, non-random and random sampling. Random sampling techniques are simple random, stratified, systematic, cluster and multistage. Whereas the non-random sampling, judgment sampling or purposive sampling, convenience sampling, snowball sampling and even quota sampling. Always we must try to use random sampling techniques. Convenience sampling, better not to use at all. It is a useless thing. Judgment sampling or purposive sampling is somewhat okay, but researchers should have a good knowledge about the population. Snowball sampling is sometimes useful. Though it is somewhat biased, there are places where it is impossible to get the information. Say for example, if you are conducting a research regarding the prostitution, you can't make a sample, you have no way of obtaining a sample of prostitutes. So you have to find one person and through her or him, you have to get the information of the others. That kind of really sensitive areas we use snowball sampling. Otherwise, we don't recommend it. Simple random sampling, stratified, systematic, cluster and multistage, they are okay. Every technique has their pluses and minuses, but they will make random samples. That means samples representing populations. So we can do a good job with random sample. So in short, what I have to tell you is, first learn the basic statistical techniques correctly. Basics. And then apply them in your field of study correctly. So as you do more and more research in the right way, so you will become a good researcher, a useful researcher to the world. I request you not to think about the number of publications. It has become a bad practice nowadays. People tend to publish something just to get the H index or citations or whatever. So stop that. Practice your techniques, then you will become a perfect researcher. Thank you.